Good afternoon, everyone. Today's our lecture's topic is circular motion. Then, what is the types of motion? It means that actual types of motions. First, we have to study it, and after that, what is the actual or what is our topic? It's a circular motion. Now, first of all, types of motion. There are three types of motions. Motion means every particle or every body comes going one place to another place because of the motion is performing every body for their movements. Okay. Then uniform motion. First type is uniform motion. A body is said to have a uniform motion if it travels equal distance in equal interval of time. It means that every particle or every body is uniformly motion. It means their moving types is uniform, and is uniform motion if it travels equal distance equal interval of time. It means that their traveling distance and for traveling distance getting how many times they are consuming this time and this distance is equal, and this type of motion is known as uniform motion no matter how small these intervals may be. It means that these intervals are very small, it's nothing matter, or its intervals are large, it's not matter, because uniform motion it means that we have to cover distance in equal time and equal distance and equal time interval of the time. Now the example, a vehicle running at constant speed of 10 meter per second will cover equal distance 10 meters every second, so its motion will be uniform. A distance time graph for uniform motion is straight line. It means that this both quantities are equal in amount, because of that their graph nature is also straight line, because y-axis and x-axis is also greater than in same proportion, and because of that their nature of this graph is straight line. Now another type is non-uniform motion. What is meant by non-uniform motion? A body is said to have a non-uniform motion if it travels unequal distance in equal interval of time. It means that in first type we have to see that there is a distance covering distance and time interval is also equal, and in this type non-uniform motion there are a few change. It's a unequal distance in equal time interval. It means that time is same but distance is unequal, or distance is not equal to the time interval of time interval. It's not equals to the distance of the body. Then a body is said to have non-uniform motion if we said that this body is in non-uniform motion. Then what is the actual position of this body? If it travels unequal distance in equal interval of time, no matter how small this interval may be. There is also no matter for how many small interval in this time. Then example is a freely ball from the certain height covers unequal distance in equal interval of time, so its motion is non-uniform. Non-uniform motion is also called accelerated motion. It means that non-uniform motion is moving in unequal distance or not counting distance. It's a random distance and their interval of time is same. Because of that their motion is called accelerated motion. That distance time graph is curved for the non-uniform motion. In first time their both quantities are vary or decrease equally, because of that their nature is straight line, but in this type there is both quantities vary or decrease not equally, and because of that their graph nature is also curved. Now why study the circular motion? To understand motion of planets. Why we have to study the circular motion? Circular motion is an also accelerated motion or surrounding. We know that the name of this motion is circular. We know the meaning of circle or circular. Circular is a vartulakar. Circular means that round shaped circle or round shaped area covered by the body is known as circular part. Then why we have to study the circular motion? To understand the motion of planets, because we all are known that our planet's motion is also circular, because our planets are circulars and they are performing or moving around each other in a circular path. Then motion of electrons around the nucleus. We also know that the nucleus is a center of the atom and electrons are revolve around the nucleus in a also circular path. Motion of giant wheels motion is also circular. All our wheels are moving in a circular motion. Motion of space stations. Motion of space stations find out for this using this circular motion. Motion of moon and satellite. Moon is also and satellite is also space science, and because of that our all space activities in the circular motion, and because of that all we have to study the circular motion, or what is the circular motion. Now what is the definition of circular motion? It is defined as the motion of particle along a complete circle or part of a circle. It means that every motion which is performing into the circular type or into the circle type, this called as circular motion. It is defined as the motion of particle along the complete circle or part of a circle. It means that every body performing their motion into the part of circle or complete circle, we know that this body is in circular motion. For circular motion, it is not necessary that the body should complete full circle. It means that in this type of motion or in this type of circular motion, body not necessary to complete the full circle. It means they are having a part of a circle. It is also in a circular motion or also performing a circular motion. It means that it is not necessary for the complete every circle or full circle. For in the circular motion, the body not completed the full circle. Even motion along arc of the circle is circular motion. Even motion is arc of the circle is known of the circle is circular motion. Arc of the circle. Arc is the few part or some part of the circle. Arc, we all are known that arc is a arc means trija. Then baga arc means trija. Then when motion along arc of the circle, circular motion. Then body is performing a small part of the circle motion in small part of the circle. Then we are also called the circular motion. Now circular motion, how do we locate it sometime on the circle? Give it angular position. It means that we have to say anything on the circular form or on the circle or in the circular motion, then we have to define this thing, or we have to define the circular motion in which type. Where here we can't consider the meter, centimeter scale because of their circular path. There is a not straight line path. And there is no straight line path, because of that we can't use the centimeter and meter scale for this circular motion. Then which scale we have to use for the measuring the circular motion? Then how do we locate it something on the circle? Give the angular position. If we have to say any circular path, the speed calculate the motion of circle or motion of body, we have to consider angular position of the body, and it's known as, or it's denoted by the theta. Theta is located, or theta is looks like a 0 and divided in between center. It's looking like a 0 which is divides in between center, or one line in between center of 0 is looking like a theta's looks. Then we have to define the angular position in circular motion is known as theta. What is the location of star? Here in this diagram there is a one star on the circle, and we have to call, then they are asked to you what is the location of this star. It means that what is the angular position of this star, and this angular position of the star is 90 degree, because of angular position of this star is 90 degree. And then we have to calculate the angular position, it's a theta, and now theta is calculated by the 90 degree. Here our angular position or our circle is divided into 4 parts, and there are quadrant or equal parts of the circle, and which equal parts are divided into the angle. It means that the circular scale we have to cannot be used in measuring a centimeter or meter scale. Because of that, here we have to use for measuring the circular path, we have to use the theta, or its unit is degree. Then theta is denoted by pi by 2. Here this sign is pi, which sign is denoted by pi divided by 2. Now circular motion, then theta is angular position, then angular displacement. Displacement is simple meaning of displacement is the we have covered the any small distance of the same time period or particular time period. It means that every body is covered same distance in same time period, or distance covered by time interval is known as displacement. Then here all those things are in on depending on circular part or circular path, and here we have to consider, or we all conditions or all concepts are related to the circular motion. Because of this, here we have to calculate the circular motion path in angular position. Then here motion or movement of this circular path is calculated into the angular displacement. Then this angular displacement is measured in delta theta. It means that measure of angular distance displacement is denoted by delta theta is equals to theta f minus theta I. Here theta f is a final position and theta I is an initial position. It means that body first of all in I position, and then is going on the position of f, it's a final position of angular displacement. And now this we have to calculate the angular displacement. First we have to calculate our initial position of angular position and our final position of angular position, and they minus or subtract each other. We have to getting the angular displacement. Then angular displacement is then 2 pi radian. 2 pi radian means 360 degree, it's a 1 revolution. Our circle's degree is known as 360. We all are known that this degree of the circle is how many? It's a 360 degree, and it's a radians means pi means 180 degree. 2 into pi means 2 into 180, it's a 360 degree. It's one circular revolution is 360 degree. Angular displacement. We know that angular displacement is defined as the angle described by the radius vector. It means that angular displacement is such as a displacement of a body on a circular path. The angular displacement is divided by angle described by the radius vector. It means that this path is calculated by the center of the circle, or this center of the circle, and joint the center and circle point present on the circle. These points and center and point present on the circle, these 2 points are joined, is known as radius or radius of the circle. We are known that the center and circular point are jointed in between them. This distance or covered this distance or this distance between these 2 points is known as radius of the circle, and this radius of the circle is called as a radius vector. Here A is the initial position of the particle, B is the final position of the particles, and theta is the angular displacement in a time. It means that the particles is going from A point to B, and this distance is theta. It's a angular displacement or motion or movement of the body on the circular path. Because of that, is called as a angular displacement. Angular displacement unit. Every quantity having a needs to unit because of their measurements. We know that every quantity or every point, every concept is need to our units, because if we know units, we can't understand what is the actual quantity of this quantity. Then angular displacement units. The angular displacement can be measured in degree, but the SI unit of angular displacement is radians. Radians means 360 degree. 2 pi is a radians. Then 1 radian is defined as angle subtended by this at the center of a circle by an arc, which is equal length of the arc divided by a radius of the circle. Then what is the definition of the radian? Is the 1 radian is defined as the angle subtended at the center of circle. It means that angle, how is angle? Its angle is connected to the center of circle by an arc. Arc is the smaller part of the circular path, and this by an arc which is equal to length of the arc is divided by a radius of circle. This length of arc is divided by radius of circle is known as radians, or is known as radian, or definition of radian. Now, one of the rules for circular motion, how we have to say the direction of circular motion, or in which direction circular motion is performing. How it's decided? It is decided to use the right hand rule. It means that the scientist is discovered that this only right hand rule, left hand and right hand, there are two rules. Here we consider, or here we study the right hand rule. In this rule, if the finger of the right hand are curled, then it says that finger of right hand's finger are curled means वळवणे, आपण एका दिशेने बोट वळवणे, fingers. Okay, then if the finger of right hand are curled in the direction of revolution, म्हणजे revolution ची जी direction आहे त्या दिशेने आपण finger curl करणं. It means that the direction of revolution our fingers is curled in this direction and of the particle. Then orientated the thumb gives the direction of angular displacement vector. Our thumb is also outstretched. It means that our direction of the movement, our direction of the finger is a horizontal, then our thumb is in vertical direction. And as like this structure, or as like this, our hand's position is known as the right hand thumb rule. And our then in this right hand thumb rule, there is a finger shows angular position, and our thumb shows the angle displacement vector. It means that our displacement vector, angular position, the directions of their angular position and displacement, we have to consider the thumb and curled fingers. Used to the thumb and curled fingers, now displacement vector is along thumb and curled fingers is also angular direction. Now here centripetal force. Centripetal force means what? UCM is accelerated motion, uniform circular motion. Why UCM is accelerated motion? Because of velocity of the body changes at every instant. We all are known that our every particle, every body are changing in every time or every instant. There is no constant or not stable any particle, any living being or any particles in our nature or in our space or in our all over earth. Then the UCM, uniform circular motion, is accelerated motion because the velocity of a body changes at every instant. It means that speed of the body changes every instant of the time. It means that there is no every body or no any body is stable condition. There is also changing into some in any instant of time. But according to Newton's second law, there must be a force to produce the acceleration. But according to Newton's second law, there must be produce a force. There must be a force to produce this acceleration. It means that according to Newton's second law is F is equals to ma. Then it must be force produce this acceleration. Means acceleration F a is equal to m a. Mass is the m is denoted by mass and a is equals to acceleration. Then force is produces as this due to acceleration. This force is called as a centripetal force. And this force is called as, in Newton's second law's force is called as a centripetal force, and also this law is also called a centripetal force law. Therefore, centripetal force is required for circular motion. No centripetal force positive no centripetal force greater than no circular motion. It means that there is no circular force, then there is no motion is there. Now, example of centripetal force: a body tied to a string and wire wrinkled. Then first of all we have to consider what is the centripetal force. Centripetal force is the force acting on the circular motion or uniform circular motion. Now, a body tied to the string and wrinkled in a horizontal circle, CPF. Then it's provided by tension in the string. It means that one body tied a string. One of the bodies tied by string and wrinkled in a horizontal circle. It means that we all are known that our string and ball is string and ball is horizontally moving, everyone or every child, and this is the playing a game like this. A body tied to a string and wrinkled in horizontal circle. Then CPF is centripetal force is the provided by tension to the string. Properties of centripetal force. Then what is the properties of centripetal force? Now, centripetal force is a real force. Centripetal force is the real force. Second one is centripetal force is necessary for maintaining uniform circular motion. It means that uniform circular motion is depending upon the centripetal force. Centripetal force is necessary for the uniform circular motion, for their maintaining uniform circular motion. Then centripetal force acts along the radius of the circle. Centripetal force acts along the radius of circle. Now we know that the centripetal force is horizontal manner or horizontal circular manner. Because of that, there acts as a radius of the circle. Then CPF is directed toward the center of the circle. CPF is directed towards the center of the circle. Centripetal force is, we know that, or previously we have to seen here, the centripetal force is directed towards the center of the circle. Then centripetal force does not do any work. This does not do any work. It's a real force or constant force. Then F is equals to mv square divided by r. Centripetal force is F is equals to mv square upon r. Here previously we have to seen that it's a Newton's second law, and a radius divided into the circular path. Because of that, there r is denoted for the radius, and our second law is F is equals to ma. Here acceleration is a velocity square. Maximum speed of vehicle on the banked road with a friction. Consider a vehicle moving along a curved banked road. It means that when a vehicle is moving on the curved blank road, then let m is the mass of vehicle, r is the radius of curvature of a road, and theta is the angle of banking. F is the frictional force between tire and roads, and the force acting on the vehicle are shown in figure. Then which force is acting on this vehicle? It's a friction. Because of that friction in between road and tire of the vehicle, and this road and tire of the vehicle friction and mass of the vehicle here consider, and this curved road is, and this vehicle is covering this curved road. Here banking force is applied on this vehicle. Conical pendulum. Definition of conical pendulum. A conical pendulum is a simple pendulum which is given a motion so that Bob described a horizontal circle and string described a cone. Here our simple pendulum, we all know that it's a mean position, extreme position, then mean position, then extreme position. But here conical pendulum is moving in the horizontal manner and stretched string in one attached to the constant surface, and there horizontally giving their horizontal motions, and this motions is performing. Then Bob described horizontal circles and string described a cone. It means that the cone, string and angle of this circular moving path is in between. The shape is also like a cone. Now the MCQs depending on the circular motion. An angular velocity of a body moving with a constant speed v in a circle of radius r is given by. It means that angular velocity of a body moving in a constant speed. It means angular velocity means distance or time or motion of the body at constant speed with v in same circle of the radius r, given by v square by r, v divided by r divided by v. Its correct answer is v divided by r, because we all are known that our radius of the body or radius vector is divided into the circle or circular path or distance. Then the cyclist turn around the curve at 15 miles hours. If he turns at double the speed, the tendency of overturn is. If any cyclist is around the curve at 50 millions per hour, if they are doubled their speed, then tendency of overturn is doubled, quadrupled, halved, unchanged. It's a quadrupled. Its correct answer is quadrupled. Then what will be the velocity vector of a particle moving in circle? Describe equal angle is equal time. What will be the velocity vector of particle moving circle describing angle, equal angle and equal time? It means that first of all we have to see the uniform motion, and in this type of motion there is a same distance and same time interval. Now here velocity vector of a particle moving in circle describing equal angle and in equal times. Change in direction remain constants. Change in magnitude change in both in direction and magnitude. Its correct answer is change in direction. Now a body moves with the constant speed in circular path, in moving circular path with constant speed. It means that body moving in circular path with constant speed. Then what is the actual position here? What is the condition is present there? Acceleration of the constant magnitude, constant velocity, constant acceleration, and acceleration which varies with time. Here constant acceleration of constant magnitude, because in circular motion there is a distance in unequal but time interval is also constant, and because of that acceleration of constant magnitude. A motorcyclist giving going with the speed, constant speed in a circular track has a stone tired a body moves with the constant speed in a circular path is moving in circular path with constant speed. Here a body is also moving in circular path with a constant speed. Then the options are acceleration of constant magnitude, constant velocity, constant acceleration, and acceleration which varies with the time. Then correct answer is acceleration of constant magnitude. Here we have to first of all we have to see in there. There the displacement or distance is unequal but time interval is also same, and their magnitude is the distance and acceleration of the constant is the time interval or direction of the circular motion. Now the motorcyclist going with the constant speed in a circular track has motorcyclist going with constant speed. Their speed is also constant in hand circular tracks. We all are known that what is circular tracks. It's a motorcyclist moving on their circular round by round in any festivals and any this motorcyclist is moving on the circular path round by round, and this is the speed of motorcyclist is constant. Now the options are there. Linear velocity is constant acceleration, angular velocity is constant, and constant force. Then what is the correct answer is angular velocity is constant. It means that there is circular position is there, and because of that it's just not straight line or linear type of velocities are present. Because of that angular velocity is constant. Because its path is circular, then here measuring type of scale is angular or circular, and because of that their angular velocity is constant. Then what could be the reason of a car moving on horizontal roads get thrown out of the road while taking the turn? It's a general thing, and it's doing or performing in everyone for by driving a car. What could be the reason of a car moving on horizontal road get thrown out of the road while taking turn? It means that we have to taking a turn, then our car is thrown out of this road. Why it's possible, or why it's going why it's possible, or why it's observing here? Because of due to the reaction of the ground, due to rolling friction force between tire and a road, by the gravitational force, due to lack of sufficient centripetal force. Which type of force is there absent or present? It's due to lack of sufficient centripetal force. Because we all are known that centripetal force is a real force, and centripetal forces get stretched to the radius and divides the arc of the circle, or stretched to the radius, or stretching to the center of the circle, and this curving surface there is a centripetal force is lack or less, and because of that their car is thrown out of the road. If a particle moves with the constant angular velocity in a circle, then during the motion then if the particles moves constant angular velocity or constant angular velocity means what? Here a circular path of the particle, then gives a angular velocity, it's constant in a circle, then during the motion and this circle's motion is what is the actual motion of this circle? In movement is conserved, energy is conserved, both energy and movement is conserved, and none of the above is conserved. Which option is right? It's a energy is conserved. If the particles moving with constant angular velocity in the circle, then during motion its energy is conserved. Now, a stone tied to a string is rotated in circle. If the string is cut, then stone falls away from the circle because then a stone tied with string, which means that one of that stone is stretched or tied with the string, and now we have to giving the motion or horizontal motion for this string or rotated in the circular type or circular path. And this circle, if the string is cut and suddenly we have to cut the string, and the stone will fall away from the circle because our path is circular path, and string also cut in between. Suddenly we have to cut the string, then our stone is feels away from the circle. Why it's possible? Why it is performing here? Because of a centripetal force acts on the stone. Of its inertia, a centripetal force acts on a stone. The reaction of the centripetal force, it's a moment of inertia. Moment of inertia, it's I is equal to mr square, radius r square. Then here we have to cut the suddenly radius or suddenly cut the string. Then it's a moment of inertia. Because of moment of inertia, the stone is out of from this circle. Now a body move with the constant speed along a circle. A body moves with a constant speed along the circle, then any constant speed body along circle, then what is the condition is there? No work is done on it. There is no acceleration produced in the body, no force acting on the body. The body has constant velocity. A body moves with constant speed on circular path. There is no work done on it, because circular path is also giving their energies and the moving around and around every time. They are not do any work in this circular path. A tachometer is a device to measure. A tachometer is device to measure. Okay, its first option is option number 1, gravitational pull. Option number 2, speed of rotation. Third one is surface tension, and last one is tension in a spring. It's a speed of rotation. Tachometer is the device to measure the speed of rotation. Now the force that keeps in the body moving in a circular motion. In circular motions body, which type of force keeping? It's a centripetal force, centrifugal force, force of a gravity, reaction force. Circular path force is known as centripetal force. There is correct answer is centripetal force that keeps the body moving in a circular motion. The mathematical expression for centripetal force is centripetal force is the Newton's second law divided by the radius. Then mv square by r, mv by r, v square by r, mv cube by r. Its first is mv square divided by r. Here Newton's second law is F is equals to ma. Here m is mass, v square it's an acceleration. Velocity is doubled, or square of the velocity is known as the acceleration, or derivative of the velocity is known as the acceleration. Then v square is the acceleration, ma divided by r is the centripetal force's mathematical equation. A body of mass 10 kg is moving with the velocity 5 meters per second in a circle of radius 5 meter. What is the centripetal force, centripetal acceleration of the body? Now here the centripetal acceleration, then centripetal acceleration is the mv square divided by r. Here which things are given? M is given, V is given, and R is also given. Then put out all these values into the formula of the mv square divided by r, and then calculated value, and which is answer is the 25 meter per centimeter second square. Then the centripetal it's a centrifugal force always acts as, centrifugal force is always acts as towards the center, away from the center, in tangential direction outside of the plane of the motion. Centrifugal force and centripetal force, both are same force and but opposite manners. It means that our centripetal force is toward the center, and at their totally opposite thing is centripetal force is a centrifugal force is away from the center. It means that every body's motion is away from the center. There is a centrifugal force acting on it, and every body having a same towards the center motion, it's known as a centripetal force. Now all those things are in this topic. We have to consider circular motion, uniform motion, non-uniform motion, centripetal force, centrifugal force, and there what is the rule for defining direction of the force. All these things are seen in this topic, and exams, in the point of view of exam, this topic is depending on a more weightage, and because of that their problems are there, as like the constant speed and variational speed, same interval of time, same interval of distance, as like this, depending on problems, on these points depending problems are asked in this exam or asked on this topic. And because of that, in this topic we have to clear the concept and more of the then practice the more problems on this circular motion. Thank you.